Hello and welcome to this screencast from Cloud9ers. Today we're going to talk about the infinite scalability platform as a service solution that we have been working on behind the scenes for maybe a few months now. So why are we doing that? The need is, in short words, proprietary platform as a service platforms are scary. Strong need exists for open source platform because actually all of the currently available platforms are proprietary. There is no standard open source solution to provide to be enabling platform for developers to write their apps on. So, as the National Institute of Standards and Technology defines the cloud, it should be on demand, self-service. Resources should be pooled and basically have lots of machines running on the cloud, and those resources should be pooled and reused for different customers. It should have rapid elasticity, so you basically scale up and scale down based on the instant load. And this should be measured service. The promise of the cloud is not yet achieved by the current infrastructure as a service providers, because basically what you have is a bunch of machines running on the cloud, and there is no integration between the software stack and the hardware stack or the cloud stack. The solution is to provide an open source platform as a service. This platform fundamentally breaks the vendor lock-in that currently exists in the market. We want to also give you savings across the board. So you start with easy and rapid development of your product. You start testing, and basically after you deploy that on the platform, everything will be monitored automatically and scaled out. The platform is an enabling technology for the developer to write easily and rapidly cloud applications. So it will be an open source, fun and easy, and it will be integrated reference online platform as a service based on an open source engine. The architecture is what we have is different interfaces for different protocols. So if you have customers connecting using XML RPC or RESTful JSON services, either web apps or desktop apps, we have interfaces for that, so you can easily write your services in different protocols, and the high performance application server will receive all of those requests and distribute the requests across your services. There is also one of the fundamentals of our platform is that we have asynchronous functor. This will take your asynchronous operations and distribute that on multiple pooled on-demand workers. Those workers are spawned up or down based on a policy that you define. Also, we are depending on distributed cache and distributed database, document-based database basically, but we want to support different types of database as well. So in this demo, we were going to show you a really brief demo of what we are doing. And in this demo, we will show you one operation that's being done asynchronously. So this chart will, I think, will illustrate how things happen. So what we're going to do, we will call one call from the web, and this call is going to execute, or actually going to feed our system with 1,000 tasks, asynchronous tasks, basically I/O bound tasks. And as the tasks are being fed to the system, workers are spawned up, and they burn down those tasks immediately. So according to the policy, what we have here is that the tasks are being fed up or in-queued to the system. So initially we have something like 25 tasks are in-queued, and in the brown line, as you can see, we have one worker running, and this worker is running fine. But as tasks are queued up, there are piles of tasks are waiting for execution. So at a certain point, as the policy defines, when we when the in-queue tasks exceed the limit of 250 tasks, we spawn two additional workers in the background, and this will help the system deal with the load more, but we're still getting more tasks, so we spawned up two additional workers, and this will really do it. This will bring the whole load down, and as you can see, the green line will steeply go down to execute all of those tasks synchronously. So what happened is that you spawned up and spawned down workers. Those workers are running in the background, and they are pooled for different customers. So they are basically reused. So either we spawn up virtual machines to do this operation on demand, or we use an already running virtual machine to do that. Okay, so it's video time. So here we will have the application server started, and we're going to request one API call that will execute 1,000 tasks. So as we do that, we have two workers now running, and you will see the tasks are being spawned and executed using two workers only. So now we have 800 and barely 1,000. So those have been executed in 19 seconds. So if we switched on the automatic scaling, this means that given the policy, we will spawn up two additional workers, and eventually what we get is roughly half the time. So thank you, and see you next time.